Hi, welcome back. In this video, we're going to work through some derivative problems that involve combining multiple rules. So these are the types of problems where maybe you need to use a quotient rule and a chain rule. Maybe you've got some derivatives of trig functions with some power rule with product rule. We're just taking our rules we know and combining them, so we're doing more than one rule at once. So here we're taking the derivative of e to the x cubed all over tangent of x. So for me, again, I see that fraction, I see e to the power of something over a tangent, and so I want to do quotient rule as my overarching rule that I start with. So if you're looking at this and kind of thinking ahead, we're probably going to need to use a chain rule also because we have that e to the x cubed. So when I look at a problem, I think, okay, I see all these parts. At some point, I'll need to take the derivative of every part. So like I see an x cubed, and so I know in my mind the derivative of an x cubed is 3x squared, and I'm already thinking somewhere in my final answer there should have been a 3x squared, so I need to make sure I get to that at some point, and for me that's going to be part of the chain rule, but we'll see that in a few moments. So okay, quotient rule is our starting rule. Let's go ahead and write out what that looks like. So we do low d high minus high d low over the low squared, at least that's how I say it. So the low function, or the denominator, is tangent. That gets multiplied by the derivative of the high function, the numerator, e to the x cubed. Then we subtract the reverse, so low d high minus high d low. So e to the x cubed times the derivative of tangent. And I guess tangent of x in all these cases. And this gets divided by the denominator squared. So divided by tangent squared of x. And I'm going to go ahead and just write the squared inside on the tangent. When we have like tangent squared or like sine squared, we can write it on the inside in that way. So I'm just going to jump to that. Okay, so we've done our first rule, we've done our quotient rule, and now we just need to take these individual derivatives. So before I even try to write anything, I just like to look at this and see like what I know without trying too hard. So the derivative of tangent, as long as you remember it or you have your reference sheet, we know that one. So the derivative of tangent is secant squared. So we have that answer, we can replace that with secant squared without much trouble. But when we're doing the derivative of e to the x cubed, that one's a little more complicated. So the derivative of e to the x is just e to the x. But here we have e to a function. It's e raised to the power of something else. So we're going to need a chain rule for that derivative. Okay, so our next part is going to be a chain rule. That's within this problem. So chain rule is next, and we're going to use that just on this one term, this e to the x cubed. So let's go ahead and write what we know. We have tangent of x times, we're doing this derivative. So the outside function is e to the x. And then the inside is x cubed. So honestly, if this were me, I would kind of just write this all out without taking this pause. So it's a little hard for me to know how to explain this in like the best way for you. So it might be that you need to just like totally pause, do this chain rule derivative separate. Like just pretend your teacher or me told you to take the derivative of e to the x cubed, do that part separate, and then put it back in. That's totally fine. I'm going to try to do this all in line because that's the way I would do it, and I think that's our eventual goal. We want to eventually become fluent enough at this that we can just like insert that derivative as we're working and not worry too much. Okay, so the derivative of the outside function, we do that first. That's e to the x, but we leave the inside alone. Remember, we're doing chain rule. So derivative of the outside with the inside left alone, and then we multiply by the derivative of the inside, which is 3x squared. So we're getting e to the x cubed times 3x squared. Then we're doing the rest of it. So we did our chain rule, we made it. Now we do e to the x cubed times the derivative of tangent, which is secant squared. And then that all gets divided by tangent of squared of x. Okay. So if I'm being honest, I would just be done. This looks beautiful. This is fine. Like, could it look better? I don't know, maybe. But I don't know. I don't know if it's worth it. So I will kind of speed up writing some simplification in case that's like what you're interested in and you want to see how it's simplified. But if you were in my class, I'd be totally happy if you got this far and just left it as is. This looks beautiful to me. So I'd leave this way, but in case I'm not your teacher and you want this to look more simplified, or if you're trying to compare with a derivative calculator, I will just speed through a simplification quick so you can see what that looks like. Okay, that simplifying was not fun, and I honestly didn't enjoy it. So I'm really grateful that I don't ask my students to simplify their derivatives, because if I didn't even like that, I don't know why most people, like, I just assume that most students also wouldn't like it. There was definitely a time in my life where I was like super stoked to simplify very like particular math things, but honestly right now I was like, I'm trying to record this video. I don't want to do all this simplifying just to make this match what the internet says it's supposed to be. So just sometimes it's more about doing the calculus, which in my mind is taking the derivative, and not so much about all the simplifying. Like, it's just not worth it if you ask me. Okay, let's do this next problem. So here we're taking the derivative of the square root of 4x times ln of x. Okay, so I see we have a square root over this whole thing, and we have a 4x times an ln x, a natural log. So for me, I see the outside as the square root. So I see that we have like this overarching thing, which is the square root that we need to deal with. And so to me, that tells me it's chain rule. I also am going to have product rule because I said the 4x times ln x, like we'll have to deal with that eventually, but I need to handle that square root. So we're going to do an outside and an inside function with chain rule. So the square root will be the outside. And to do that, like carefully, I am going to handle it as a to the power of 1/2. So just for my own sake, before we even start, I'm going to write this as 4x ln x to the 1/2 power. So that's how it makes the most sense to me, is to do the square roots with the 1/2. And honestly, we're going to have to do that anyway when we do power rule on it. Okay, so we're going to do chain rule. I have an outside function and an inside function. The outside function is something to the 1/2 power. So I like to pick like the part that's really freaking me out. Like the part that's freaking me out here is the square root. I do not like it. So the outside function is something to the 1/2 power. So it's the square root of x, or x to the 1/2 power. That's our outside function. Then the inside is everything else that goes in that x. So the inside is 4x ln x. Okay. So when we go to do chain rule, we do the derivative of the outside function with the inside function left alone. So let's just do that first. So the derivative of the outside function is 1/2 x to the negative 1/2. So the 1/2 comes down, and then I decrease the power by 1. So if you want to take a second, you could write it as 1/2 minus 1. And we leave the inside left alone, 4x ln x. That's my derivative of the outside, inside left alone. Then I'm going to multiply by the derivative of the inside. So that's the derivative of 4x ln x. Okay, so we've done part of it. We took the first part of the derivative, which is the derivative of the x to the 1/2, or the square root, the something to the 1/2. Now we need to handle that derivative of 4x ln x. So within this problem, we're going to have to do a product rule on this little part. So this is going to involve a product rule. Okay, so we can rewrite the part that we're already done with. So that's the 1/2 times 4x ln x. And then 1/2 minus 1 is negative 1/2. And I'll continue simplifying that with each step, just changing that negative exponent to a positive, putting it as a square root in the denominator, that whole thing. So you can anticipate us kind of doing a little bit of that each round. Okay, then we need to multiply by our derivative of 4x ln x. So 4x times ln x, to me that's a product rule. I'm going to take 4x as the first part and ln x as the second part, or the first term and the second term. I'm pretty sure that every time I do this, I change which derivative I take first. Like sometimes I take the derivative of whatever's listed second. Sometimes I take the derivative of whatever is listed first. Like honestly, it's really hard because with the addition, the order doesn't matter. Anyway, let me get to the point. Let's take the derivative. So let's take the derivative of 4x, and then we'll multiply that by the other function times ln x, and then we'll add it to 4x times the derivative of ln x. So this is our product rule. We take the derivative of one of the terms, multiply it by the other, and then we add it to the opposite. All right, so we're just going through and simplifying this, or finishing the derivatives, I guess. So I'm going to rewrite that negative 1/2 as a positive exponent in the denominator. So we're just doing a little bit of simplifying with each step here. So 4x ln x now has a positive 1/2 exponent since we've moved it to the denominator with that 2. Now we're going to multiply by this whole other derivative, which is the product rule. So I'm going to keep my big parentheses just so I don't lose anything. The derivative of 4x is 4, and then we have ln x. We add that to 4x times the derivative of ln x, which is 1 over x. Okay, that actually wasn't too bad. I don't know why that was freaking me out. We made it. Okay, now let's just simplify everything. So now I'm going to take that 1/2 power and write it as a square root. If I was given a square root in the problem, like the radical symbol, I like to get back there in my final answer. To me, it's just like it's kind of clean to do that. So we're going to write this as the square root of 4x ln x. Now, this gets multiplied by this other stuff. I'm going to try to simplify it just a little bit. I see those x's are going to cancel. So that's 4 ln x plus 4. And there we go. I might take one more step, but this is done, okay? This is the final answer. This is fine. I'm just going to write this as one fraction instead of having it separate. Let's move this 4 ln x plus 4 to the numerator, and then we'll have the 2 times the square root of 4x ln x. This is the final answer, and honestly, I would be very happy with this if a student submitted this. This is just fine. I trust that you could simplify some 2's and some 4's. Like, that's not a big deal. Oh my gosh, we've been working for so long. Derivatives are tiring, you know? Like, it's a lot of math to do. Okay, we have 2 more examples left. Let's work through them. All right, so here we have the derivative of x e to the x over 3 sine x. So we have quotient rules since we have one thing divided by another thing. And I'm also seeing like x times e to the x. That's probably a product rule. So we can handle it. It's gonna be okay. All right. My first rule is going to be quotient rule, since that is sort of my main thing I need to handle. I don't know where I would start if I didn't start there. Okay, low d high minus high d low all over the low squared. So low 3 sine of x times the derivative of the high times the derivative of x e to the x minus high x e to the x d low derivative of 3 sine of x. And then this is all over the denominator squared. So 3 sine of x quantity squared. Okay, I can pretty clearly see the derivative of sine of x. Like, that one I know how to do, that's the cosine. But the x e to the x is going to take another extra step because that is a product rule. There's 2 things being multiplied together that are functions. So we're going to try to do this in line and not write out something extra. So we are going to do a little product rule just on that little piece, but let's see how it goes. So 3 sine of x. We're going to do product rule in this part. I'm going to put it in parentheses. So we'll take the derivative of the first, that's 1, times e to the x, and then we'll add it to the reverse. We'll leave x alone and multiply it by the derivative of e to the x. But the derivative of e to the x is just e to the x. So there we go. Okay, now we just keep going. We have minus x e to the x times the derivative of 3 sine of x. That's just 3 cosine of x. And then this all gets divided by 3 sine of x squared. So here, I just want to really make sure we notice that we do the squared on both things that are here. So we're going to do 3 squared and sine squared. You could probably just leave the squared on the outside, but I just want to go over it in case this is a sticking point. Okay, so we're technically done. We did the derivative. With that product rule, I think I'm just gonna like clean it up a little bit. Let's just clean it up just a little bit, not too much. Okay, 3 sine of x times e to the x plus x e to the x minus, let's do it as 3x e to the x cosine of x. I don't know, that's just the order I like to write those things in. Okay, and then that all gets divided by 9 sine squared of x. And I'd be so happy with this. This looks great. So I don't know if it looks great, it's kind of a mess, right? But to me, this is a completed derivative. This is like what we're learning in calculus. We're learning how to take derivatives. You did it at this point. You finished the derivative. So if you wanted to simplify this more, I don't actually think it gets much prettier. If anything, you should just be canceling the 3 and the 9, or like simplifying, right? So 3 over 9 is like 1/3. So those 3's could cancel. You'd just have a 3 in the denominator. So that might be what you simplify, but actually I think we should just leave it like this. Okay, and now we are on to our last derivative. So here we have the derivative of cosine squared of x to the 5th. Okay, so cosine squared of x to the 5th. Just since I have like of something that is not x, to me that tells me we're going to have to do chain rule. But I also have that cosine squared. For me, when I see the cosine like with the squared written on the inside, that's like a standard way of writing it, but it's kind of like when we have a square root. For me, it's hard to see what's going on. So I'm going to rewrite that with the squared like on the outside before I do anything else, just to orient myself for what rules we should be doing in which order. So we're going to do the derivative. Here we really have cosine of x to the 5th, and then this whole thing is raised to the 2 power. It's getting squared. So cosine of x to the 5th squared is what we're looking at. Okay. Now for me, I see this as more easily having like an outside and an inside function, so I know where to start. So for me, I see that we have something squared. So we have this cosine x to the 5th squared, and then I have cosine of x to the 5th. So there's gonna be like a handful, well, there's gonna be 2 chain rules that we have to do. Let's just start with one. Let's not get too ahead of ourselves and just start with the thing we see, or at least I'm hoping we see, which is the something squared and the something on the inside. So we're doing our first chain rule. My outside function is x squared, or something squared, and my inside function is all that other stuff. So the cosine of x to the 5th. Okay, so now we're going to do our chain rule. We do the derivative of the outside with the inside left alone times the derivative of the inside. So let's go ahead and write that. Derivative of the outside is 2x. So 2, and then instead of x, we have whatever we started with, cosine of x to the 5th. And we're going to multiply that by the derivative of the inside. Okay, so we've done our first chain rule, and now we just need to handle this like derivative of the inside function. So I guess we haven't technically finished the first chain rule, and we're working now on that like other derivative. And to do this, we're going to need a second chain rule. So we have cosine of something that isn't just x. So the derivative of cosine is negative sine, but I know we're gonna need a 5x to the 4th somewhere, right? Like I need the derivative of every part of this. So x to the 5th, the derivative is 5x to the 4th. That's gotta show up somewhere. Okay, so another chain rule. Here our outside function is cosine, and the inside function is x to the 5th. Okay, so 2 cosine of x to the 5th, and then we have multiplied by this next derivative, which has another chain rule. The derivative of the outside is negative sine, and we leave the inside alone, so negative sine of x to the 5th. Then we take the derivative of the inside, so the derivative of x to the 5th. So derivative of the outside is negative sine, leave the inside alone, times by the derivative of the inside. And we're almost there. We can write our final answer. I think we can. So we're going to have 2 cosine of x to the 5th times negative sine x to the 5th times 5x to the 4th. And we're technically done. I'm gonna write one more step. I can't help myself. We gotta simplify just a little bit. So combining the 2 and the 5, we get 10. I'm going to move the negative and the x to the 4th on the outside. So we have negative 10 x to the 4th, and then I have my cosine of x to the 5th and my sine of x to the 5th. Okay, and there we go. That is our final answer for this derivative. So we did one chain rule, and then we had to do another one just to finish it off, and there we go. All right, I really hope that this was helpful for seeing how to do derivatives when you have multiple rules at once and sort of figuring out what to prioritize or what steps to take. If you have any questions, leave me a comment or just leave me some nice words. It also helps a lot if you like this video, if it was at all helpful, or subscribe. I'm really trying to grow this channel so that we can get this content to more people and help them with math. I love doing this type of thing, and so I just want to get this to other students and other people learning math so they can get support. So give me a like and subscribe. It actually really helps. It does do something, and it shouldn't really affect you on your end too much other than clicking those buttons. So, okay, thanks so much, and I will talk to you in the next one. Bye.